Hello and welcome to my channel. In this math video tutorial, I want to discuss definite integral. The definite integral of any function can be expressed either as the limit of a sum or if there exists an antiderivative f. Alright, for the interval say a across b. Then definite integral of the function is the difference of the values at point A and B. For example, if I have an integral of the entire, or there's a function, let's use a function x dx. So the result of this will be the antiderivative of this x plus constant c. And this is what we call the indefinite integral. Alright, so I'll show you the sample of how the definite integral is, like what we just explained, that the definite integral appears to be in this form from point A to B of a function, say x, the x, and the result to this will be the antiderivative of this point B to the antiderivative of point A. Alright, what this essentially is talking about is, for this particular one, which is the indefinite integral, you would see something of this sort: the integral of x to the power of n dx. And this will give us a formula which is x to the power of n plus 1 all over n plus 1 plus constant c. So notice for this definite integral, we did not add constant c because it's not necessary. And then for the indefinite, we added constant c because after you would have integrate any function, you must add constant c. That doesn't mean we can't add constant c on this. We can, but then it will always cancel out. Maybe when we start solving problems, then we can be able to demonstrate what exactly I'm talking about. So for the definite integral, we have what we call the upper limit and the lower limit. Alright, so but for this indefinite integral, it's just the way you're seeing it. You just integrate and that's all. You add constant c after your integration. So let's start seeing problems that we can be able to demonstrate using these definite integral. So the first problem I want to introduce to us is something of this form. We have the integral of this question 1. So let's simplify the integral of 4 dx from 1 to 2. So how are we going to work on this problem? It's simple. The first thing you need to do is to say, take the integral of this 4 with respect to x, and the result of that will be 4x. Alright, so now you have from point 1 this lower limit and this is the upper limit. So what essentially is this talking about? It means we're going to make some sort of substitution. You substitute this 1 for x and also substitute 2 for x, and then finally this is the result you have. This will turn out to be just like this expression you have here. When you have the integral from point A to B, what you need to do is to just take that of the upper limit minus that of the lower limit. So in this case, we have 4 into wherever you see x, replace it with 2, which is the upper limit, minus 4, and then this is the upper limit, lower limit represented here. So what we have here is, you can add plus constant c, but that will not be necessary because if you add c here and add c here, definitely they will go. So 4 multiplied by 2, that will give us 8, minus 4 multiplied by 1, that is 4. So 8 minus 4, the result is 4. So you can see in this case, we don't usually have, we just have real numbers. So we don't have constant attached to it plus constant c because it's not necessary. You definitely cancel out by the time you make this substitution. So that's the difference between definite and indefinite integral. So let's see another example. Example 2. Let's take the integral of, say, a function to x plus 1 from point 2 to 3 dx. So pause the video and attempt this problem. Alright, let's see the solution together. The first thing we're going to do is to integrate this function. Of course, when you're taking the integral of this using the same formula I've introduced, which is the integral of x to the power. This is the formula for indefinite integral. The result of this will be the integral of n to the power of x to the power of n plus 1 and n plus 1. Whatever you have here is still photocopied and drop it down there, plus constancy. You will always add this, but for this we just take the integral of this and also the integral of this. So what do we do at this point? The integral of 2x dx will give us 2 to the power of course there is 1 here which represents this n. You add it to this other 1, so you have 2 to the power 2x to the power of 2 divide by 1 plus 1, that will be 2, and then plus the integral of 1 dx will just be x. Alright, so the whole of this we have from point 2 to 3. So of course you know that this will easily cancel out. So what we'll be having, this implies that we'll be having x squared plus x from point 2 to 3. So what is the next step here? It's just to make the substitution. So at this point we're going to substitute the upper limit, which is 3 squared plus, we have 3 here, minus the lower limit, which is, you can just put it in the brackets, the lower limit we have is 2 squared plus, and then we have here to be 2. So what's the final solution to this? 3 squared is 9 plus 3, and then here we have 4. 2 squared is 4 plus 2. So what is the result of this? 9 plus 3 give us 11. Sorry, that will give us 12. Minus, and what is 4 plus 2? That will be 6. And then 12 minus 6, the result of this is 6. Of course, it gives a real number. There's no constant attached to it. Alright, let's see another problem on definite integral. I opted this question from JAMB past question paper. The value of this, we want to see which one of these options will best fit the solution to this problem. So let's see how we can solve it using the knowledge we've gotten already. So the first thing that we need to do here is to take the integral of this x squared. And of course, the integral of x squared will be s squared plus, that is 2 plus 1, that is 3, s cubed all over 3. Alright, minus the integral of this will be 2x squared over 2. Alright, if you're having challenges in understanding how we are taking this integral, then I'll drop the link in the description of this video, the tutorials for the basis of integration. So from there you can be able to pick up, you come back to this video, and then you start understanding how we're taking this integral. So this will eventually cancel out with this, and then what we'll be having here is x to the power of 3 minus, or divide by 3, minus x squared. Right, so the next point here is to, of course, you know, by the time you take the integral of each of these, you have here 0, and we have here 1. So the first thing is start plotting the upper limits. So substitute 1 in this case. We have 1 cube over 3 minus 1 squared, and this will be in brackets minus the next one is 0 cube over 3 minus 0 square. So what's the next point here? 1 cube is 1, and then 1 over 3 is still 1 over 3 minus 1 squared is 1, and of course everything here becomes 0 because 0 squared is 0. 0 to the power of 3 divided by 3 is also 0, so the whole of this will go. So this is essentially what we're having remaining. So 1 over 3 minus 1. Let's make it a fraction over 1. After all, 1 over 1 is still the same thing as 1. So the next thing is to work on this fraction, which is simple. 1 multiplied by this 1, the result will be 1 minus 3 multiplied by this will be 3 divided by 3 times 1, and that will be 3. So the result here will be 1 minus 3 is minus 2 over 3. You're surprised about the method of this. Instead of looking for the LCM, and you can just do it. That's a short way of working on this. So the result is minus 2 over 3. Let's check the option, which one is best. Okay, this is the solution to it. Alright, so let's solve more problems on this definite integral. So we have the integral of 9 over x dx from 1 to exponent. Okay, so the first thing we need to do at this point is to rearrange this equation, this expression here, in such a way that we'll be able to work on it. So here is the same thing as saying the integral of course, here is the same thing as 9 is a constant. This, if this multiplies by 1 over x, of course we're having this same expression, the x, from point 1 to e. 9 multiplied by 1 is the same thing as 9 over this x. So what do we need to do? This is a constant, so let's take it out. So we have 9 integral of 1 over x from point 1 to e dx. So this essentially would be the integral of 1 over x is ln x. Alright, the integration of 1 over x dx. The result of this is ln x. Alright, so here we have 9 multiplied by ln x. That's the integral of this from point 1 to e. So what do we need to do at this point is to make the substitution. So I have 9 ln e minus, the next one is 9 ln 1. So what do you think is the solution to this? Pause the video and then drop the answer, or whatever I think to be the solution of this problem. Drop the answer in the comment section. Thank you, and make sure you like this video, subscribe if you've not subscribed to my channel.